So in our previous example, we learned to solve for centroids on a complex shape using what we called the addition method. And I want to differentiate the addition method with the subtraction method by doing the exact same shape as before. So same example as before, but with the, let's put a comma there, but with the subtraction method, which we'll learn now. And you'll see why we call one the subtraction method and why we call one the addition method, hopefully in this video. But and let's say, keep everything simple this time. Let's make it a scale of 1 to 1 instead of a scale of 2 to 1 like in the last example. The reason why we call it the subtraction method, let me go ahead and make this grammatically correct, is because we're going to actually subtract instead of adding. We're going to take away from a total shape instead of combining multiple small ones. So let's go ahead and get started by redrawing the same shape as before, just to a smaller scale, so 1 to 1. In other words, if it's 6 inches long, we're going to make it 6 squares long. So we're going to go up 1, 2, 3, 4, 5, 6. And we're going to go 1, 2, 3. Oops, let's fix that. 1, 2, 3, 4, 5, 6. Drag it over. Then we'll go 3 over here. And so you can see it's the exact same shape as before. We're just drawing it to a smaller scale to make our lives a little bit easier. Let's go ahead and mark it with a reference point down here. RP. And I went ahead and made it a darker color. But it looks like I accidentally changed the color of this as well without noticing it. So let's change that back to maroon there. But then let's go ahead and label this. Let's say this is 3 inches here from this point to this point, just like before. And then this will be 6 inches from the end of our shape all the way to the beginning. So left to right, 6 inches, just like before. So as I said several times now, it's the exact same as before, just to a smaller scale. So this is 3 inches, and then of course this will be 6 inches as well. And you might notice that my extension lines aren't going all the way to my shape. That's for a very good reason. And that's because we're going to add a shape. Instead of breaking this into smaller pieces, let's go ahead and make this one bigger piece that we actually cut out of. So what do I mean? Well, if you notice, this kind of makes a total square if we use our imagination here, if we make this a total shape. Where this would be shape 1, this gigantic square here, and then this cutout triangle could be shape 2. And so what we're actually going to do here is we're going to calculate the centroid for the entire shape and then subtract the centroid of the tiny triangle. So to do that, well, we need a couple things. First off, we need to know the area. So let's find the area of our first shape. Well, it's a 6 by 6 square if you count the extra bit that we're going to subtract away. So that 6 by 6 is a 36 inches squared area. Whereas our second shape has an area of, well, it's a triangle. And our triangle has a base and a height of both 3. So the formula for the area of a triangle is the base times height divided by 2. So 3 times 3 is 9, divided by 2 is 4.5. Next thing we need is the centroids for both. Well, this is just a simple square, so the centroid would be right here in the middle from here to here, 3 away from our reference points. Let's go ahead and draw the centroid and give it its cross and then fill in the space as well. Where this distance would be my x distance for shape 1 from my reference point to my centroid of shape 1, okay? And this would be my y distance from my reference point to my centroid for shape 1, or I'll just call it y1 just to keep it life simple. And what are those numbers? Well, our x1, or x distance, is, for our first shape, is just 3 inches from our reference point. Whereas our y distance, well, who we guessed, is also just 3 inches from our reference point. Now, as for the centroid for a triangle, we learned that, okay, it's just 1/3 of the base and 1/3 of the height. But we're going to start from this corner up here to find the centroid, so it's 1/3 of the way, 1/3 of the way. That makes sense. It'd be closer to the corner than it would be to anything else, to any of our, or the corner of the 90-degree angle. But that's only one away from that corner there. We want to know the distance of it from the reference point. So we've got our x distance, so our x distance from our reference point for shape 2 of our centroid, and then our y distance. from our reference point to our shape 2's centroid. And what are those numbers? Well, our x distance for shape 2 is just 5, and it's the same for our y distance as well. They're both just 5 inches from our reference point. You might be thinking to yourself, okay, well, how is this different? Well, the way it's different is because the area is actually negative for our shape 2 because we're cutting out that area. It's 36 inches for the area of one shape, or for the whole shape, but then we have a cutout. So this is actually a negative area, and that's how it changes. That's what makes it the subtraction method. Other than that, we're just going to plug it in the same way to our formulas from before. So we got our x total formula, which was the sum of all x individuals multiplied by area individuals, and we'll put that all in parentheses. So the sum of all these numbers divided by the sum of all area individuals. And then we can do the exact same thing for our y total. It's the exact same formula, just with a y instead of an x. So we got the sum of all y individuals multiplied by their area individuals divided by the sum of all area individuals. And so to solve for x, what are we going to do? Well, we're going to say the x total equals the sum of all. Okay, so I'm going to go ahead and draw myself a bar here. The sum of all x individuals times area individuals. So that's 3 times 36 for the first one, 3 times 36. And we're going to add that to our area multiplied by x component. So what is that? That's 5 times its area, which is negative, very important that you remember that, negative 4.5 area. And then we can divide that by, well, just the two numbers, which is just 36 plus negative 4.5, which we will just call minus, because positive and negative make a negative. 36 minus 4.5. And then we can even simplify it from here. We could say, okay, well, 3 times 36, 3 times 30 is 90, 3 times 6 is 18, so 108. And then we could say 5 times 4 is 20, 5 times 0.5 is 2.5, so we could say 22.5. And then, of course, positive times negative is a negative. And then we can divide that by what would it be? 36 minus 4.5 would be 31.5. And that bottom number might look familiar from before. It was the same bottom number we had before in our proportion and our addition method. But 108 minus 22.5, that is, surprise, surprise, a very familiar number as well, 85.5. If you look back at our previous examples proportions, right before we got to our final answer, you'll notice that we had the exact same proportion. And that makes sense, since we're calculating the centroid for the exact same shape. So what is that? Well, if we type that into our handy-dandy calculator, just like before, 85.5 divided by 31.5. What do we get? We get, oh, who would have guessed? Our x total is still 2.7 for the exact same shape. We're just using a different method to do it. But of course, we can do the exact same thing for our y total. So what is it? Well, if you notice, the y components are the exact same and the areas are the exact same. So it's really the exact same formula again. It's still 3 times 36 plus 5 times negative 4.5. So I'm just going to copy this down to save ourselves some time and place it right here. And then I'm not even going to do the math because we already did it, right? I'm just going to say, okay, equals 2.7, and that is, well, let's go ahead and write it out, is our y total distance. So then we can go ahead and mark these for ourselves. We can say our y distance is a little bit less than 3, which would be about 2.7 right here, and our x distance is about right here at 2.7, a little bit less than 3. And combine those. Hold on, let's go ahead and draw ourselves a little dotted line. Follow the yellow brick road, right? And we can do the same thing in orange to make color coded. And then I'm just going to go back to the original color for our centroid total, which is right here. And again, surprise, surprise, it is along our line of symmetry, which is kind of a rule for centroid. So as you can see, you could use either the addition method or the subtraction method if the question allows for it to solve for the same shape. You get to kind of choose based on what is the simplest for the shape given. So hopefully that wasn't too incredibly painful. But let's go ahead and label this last one as the centroid total right